Welcome to Sodexo Global Lean Six Sigma for Services. I am John Tiffany, the Lean Six Sigma Master Black Belt for Sodexo North America Corporate under Business Improvement and Growth Support. I will be providing instruction for several of the classes in the Green Belt Tool Belt curriculum. It's about leadership. The whole purpose of this instruction is to make you a better leader for our company or yours, and to make you a better trainer for future leaders. As you go through this Green Belt course, most of what you will learn will be about finding root cause and improving process performance. You must have a thorough understanding of everything you learned in our Yellow Belt program, or you will not do well in this Green Belt training. Please review Yellow Belt skills, especially statistics, before proceeding. This class is an introduction to the Complex Issues Leverage Matrix, the CILM. The CILM is used only after everything else fails. The CILM is used in complex situations where there are several faults and several root causes. And the CILM helps to develop solutions that are grouped into solution sets, and then one of those solution sets is chosen. The CILM is used mostly in the Analyze step to identify multiple root causes, solutions, and solution sets, but it is also used in the Improve step when the solutions that were identified are implemented. The purpose of this class is to give you a good understanding of the major steps in learning how to use the CILM. Here is our agenda. We will go through each one of these steps and activities in detail. You may have noticed that many of the root cause analysis techniques we've looked at make the assumption that there is one root cause to one effect. And that might be so in some situations, but generally I found that there are more than one root cause associated with an effect, or that a root cause can be associated with more than one outcome, or that root causes can be sequential, leading to one or more outcomes. So what do we do to fix this? Well, we try the Complex Issues Leverage Matrix, which assumes that there can be a fault that has more than one root cause, or that fixing a root cause can fix or partially fix more than one outcome, more than one fault. This helps in the Analyze step when the Analyze step stalls, because people will comment, well, I understand you've got a solution to one of these faults, but what will it do for me and my fault? Well, the CILM takes into account that there can be more than one fault, and there can be more than one solution, and that the solutions can be put together in solution sets. And the CILM is expressed as a matrix, and these are the steps in filling in the matrix. The first step is to identify the faults, and there will be several, and we prioritize these if they are not received in some kind of prioritization, like from a Pareto analysis. But if they're not, then we prioritize them using the severity and frequency of occurrence method. Then we identify a root cause for each one of the faults. And sometimes we find that one root cause tracks to more than one fault. So we indicate that on the matrix. And then we identify solutions, one for each one of the root causes. And we often find that a solution will track to more than one root cause. We then identify solution sets. Which solutions do we have to do to get pretty thorough coverage of the root causes? And there usually are 2 or 3 or more solution sets. Any of the solution sets is roughly equal to the other solution sets in addressing faults. So we look at the solution sets and determine which one of those, or which ones of those, we will select for implementation. That's usually done by a cost-benefit analysis. So we select the best solution set using the Kiln matrix. The inspiration for the Kiln was probably the decision matrix developed by Ben Franklin in 1775, and that led to development of a leverage matrix, which led to the development of the complex issues leverage matrix back in the 1980s as a method to place intelligence assets in the most valuable places. It's since turned into a method for design of systems and for solving complex problems. Kiln has been used by the United States military, also by Raytheon, Thales, Boeing, Lockheed Martin, Boehringer Ingelheim Pharmaceuticals, Tonell Corporation, the FDA, and several other companies. Here is a schematic of a Kiln. It starts with a listing of the problems, or UDEs, undesirable effects, or faults, in precedence from left to right. So each problem gets a column. We usually turn it sideways and write it in there using an Excel spreadsheet. And every one of the problems is there in relation to the other problems that are also present. So the most important problem is all the way on the left. For each problem, at least one root cause or likely root cause is listed then on the left-hand column. When the first root cause is written down, it's tracked to the first problem, and an X is placed at the intersection in that little matrix that's called tracking root cause to problem, where those two intersect. And then that root cause might affect some other problems, not just the one problem that it was designed for, but it might affect other problems. So an X is put in those also. Well, then again, it might not completely solve a particular UDE or fault, but it might impact it a little bit favorably. And so instead of an X at that intersection of the root cause and problem, an O is placed in there, a capital letter O. So then the next root cause is developed and tracked to whatever problem it was meant to solve, and maybe to others with another X or 2 or 3 or 4. And then an O can be placed at the intersection of the root cause and problems where there's a partial solution or a partial resolution of the problem. Then solutions are developed. A solution is developed for the first root cause, and an X is marked where there's an intersection of that root cause and the particular solution. And then you go down the column for that particular solution and see if it addresses other root causes. In the same way, then, you put in an X or an O. It completely solves that root cause or addresses that root cause, or it does something that helps it, and that would be an O. We'll look at those in the following slides. A Kiln in process may look something like this. Notice on the top there's a listing of faults. Here there are 10 of them, and they're arranged in order of precedence, 1 through 10. The most important fault is number 1. There could be fewer than 10, there could be more than 10. I've often done these with about 20, maybe 21, but I try to cut them off at less than 10, fewer than 10. It's a little bit easier to work with, and in most problems there aren't that many faults that absolutely have to be addressed. Now go to the left column, see the root causes are listed. I've replaced the root causes with numbers, but if root cause number 1 were written in, it would be for fault number 1, and so there would be an X placed where row 1 and column 1 intersect. So root cause number 1 thoroughly addresses fault number 1. Now whoever owns fault number 2 might say, well, that'll help me out too. If you address that root cause, it'll address part of the fault on mine, number 2, and so you put an O in that spot, and then whoever owns fault number 6 might have said, hey, that root cause also completely addresses fault number 6, so you put an X in there. Fault number 9, well, it's a partial fix. And then number 2, root cause has come up, is addressed for root cause or for fault number 2, and you see the X that is at the coincidence of row 2 and column 2. That means that root cause number 2 thoroughly addresses fault number 2, and then whoever owns fault number 4 says, well, that would also fix my fault, and so they put an X in there. Whoever owns fault 10 here evidently has said that also would fix fault number 10, so you put an X in there. But you can see how this develops. If you do it correctly, and you develop one or more root causes for each of the faults, there should be something like a diagonal line of X's across the field that shows the intersection of root causes and faults and their assignments one to the other. After you have done all of the root causes and addressed all of the faults, with each one with at least one root cause, then it's time to develop the solutions. The first solution is developed for the first root cause, and so there will be an X in that spot, which is the intersection of the column for solution 1 and the row for root cause 1. After that solution is developed for that particular root cause, you go down that column for that solution and say, hey, you know, it could be that if we implement that solution, it'll also solve root cause number 2. So I'm going down with solution number 1. I put an X in the second row. And then whoever looked at the root cause number 3 will say, well, that also addresses my root cause. And so you go down the column filling in X's each time an X thoroughly addresses a root cause. And when there's a partial hit on a root cause, you put in an O. Where there's no relationship between the solution and the root cause, leave it blank. You continue developing solutions for each one of the root causes. Now in this example, some of the root causes have been shifted around so that they're in what we call solution sets. There's a green solution set, a blue solution set, a pink solution set, and a gold solution set. Notice that whichever solution set you choose, all of the root causes will be addressed. So green solution set has an X across from every root cause. It's either in solution 1, 2, or 3. Blue has a solution for each root cause. Notice they're going back and forth across these two solutions. Pink has a solution across from each root cause, and so does gold. Now, how do you choose which solution set to choose to implement? Well, you do a cost analysis. Look how much time it takes to do each one of the solutions and what the cost might be in dollars to do each one of the solutions, and maybe there's some other consideration. It could be a presence or absence of a union of some kind, or a simple preference of the clients. But all of these are put together, and then a cost-benefit analysis is done using the time, dollars, and other for each one of the solution sets. And you can then make a determination on which solution set to choose, noticing that whichever one you choose will have roughly the same effect on the root causes, which means that each solution set, whichever one is chosen, will have an effect on the faults, roughly the same effect. Here's a photo taken many years ago of a friend of mine doing a CILM project we were working on in Brazil, and you can see there are 7 different faults that are identified on the top left of this whiteboard Kiln, and then root causes are listed on the left, and there's a tracking that's done just with X's. In those days we were just using X's, not X's and O's, and you can see that there's a number underneath each one of the faults. We had prioritized them using a severity and frequency of occurrence type of formula, and I believe there's a tie on the precedence for number 5. But you can see that they're listed here, and then we started to develop the solutions and the solution sets. We found it easier to do it on a whiteboard before we put it on Excel, and I still find that easier today to put it on a whiteboard and then transfer it as we go to Excel. You may find it to be easier with whiteboard or wall and post-it notes. But whichever method you choose, first list the faults, prioritize them, then develop the root causes, then develop a solution, then another solution, then another, and all the while track the root causes to the faults and the solutions to the root causes, and then develop the solution sets. Here's the start of a Kiln. Let's look at it and we'll go through step by step what to do. Of course, one of the first things to do is get a listing of faults. Some people call them faults, some people call them UDEs, or undesirable effects. Other people just call them problems. But they should be listed, and then it's a good idea to assign somebody to each one of the faults. It is important to assign a lead to each one of the faults or UDEs or problems. That person or persons must know exactly what's meant by the terms you put in there to identify the name of the fault. Like, what does it mean? What is an LRU, infant mortality? What does that mean? Something about a line replaceable unit, but I'm not sure what you mean. Dana would be the one I would go to if I ever had a question on that. Dana would be the one who would write down the definition of that particular fault when we do a final report or recommendation for an action. Here are the faults before we did the prioritization. You see the 11 faults are listed on the top of the matrix, and there's a name associated with each one of the faults. That's the lead for each one of the faults. And then below it is a number for frequency and severity. To go through this, Mike would say, well, this is what I mean by LRUs not tested and so forth. He'd explain it, and then he would say, this is what I believe the frequency is, and this is what I believe the severity is. And the team would discuss it, and maybe they'd adjust the numbers up and down. If there's a disagreement about it, we agree with Mike's expertise, and we assign it the numbers that Mike wants assigned. The only one who can override Mike on these numbers is you as the team lead. Next, Annie and Naveed explain test line replaceable units and so forth. They explain that problem, they give it a frequency number and a severity number, and the team goes through it again and they adjust the numbers up and down, and it goes like that, the same process for each one of the identified faults. After you've done it, after you have a frequency and a severity for each one of these, we go back and do it again. Now, why do we do that? Because when the team goes through the process the first time, they're getting calibrated by what they really mean by a frequency and a severity. Frequency and severity both range from 1 to 10. 10 is bad, 1 is not as bad. But when something is given a frequency of 10, that means every possible time it can occur, it does occur. And a 1 means it almost never occurs. Severity is something that absolutely stops the process. Every time it happens is a 10. Or it's something that causes of loss of life or limb or eye. That would also be a 10. And then a 1 is something that's negligible, hardly worth mentioning, but you do mention it. So there's a range of 1 to 10 for severity, and there's a range of 1 to 10 for frequency. After, only after, you've done the frequency and severity and gone through it again and decided on the numbers, you add another row and you show the frequency score multiplied by the severity score. So 8 times 8 is 64, 3 times 8 is 24, and so forth. And that new number, some people call the risk priority number. And that's the number we use to prioritize the ordering of the faults. So you can see we have a 100 over here. That's Debbie and Dave's fault called throughput/capacity. And that looks like it's going to be number 1. Now, what do you do if you get a tie? If you get a tie, then the one that has the higher severity number is considered to be higher. And if there's a tie in severity and frequency numbers for a fault or two, then you go back to the experts and you ask them to work it out. So if I had a tie between a couple of these and Mike owns one and Eddie owns another one, I'd ask them to talk and ask for them to put them in some particular order. If they can't, then I would do it as a leader of the team. But this is how you prioritize the faults for resolution if they don't come to you in a prioritized list. Here I've added another row to show the priority for each one of the faults. So the fault that's owned by Debbie and Dave is number 1. Number 2 is the fault that's owned by Art. Number 3 is the fault that's owned by Mike. And then I'll sort these left to right so that throughput capacity is all the way on the left. The next one would be supplier testing inadequate. And then the next one after that would be the one on LRUs and so forth. But I would prioritize all of these from left to right based on the risk priority numbers. After you've prioritized these faults and listed them from left to right in order of precedence, then copy the data but get rid of it. You don't need it on this particular slide. We're going to keep for our work on the rest of this matrix, the rest of this CILM, but I do keep the numbers in case somebody wants to revisit them. Meanwhile, I erase everything except for the fault and the name of the person or persons who own that fault. Now we start developing root causes and tracking those root causes to the UDEs. So Debbie and Dave start off by explaining again what throughput capacity means, and then they explain what they think is the root cause behind it. Since that root cause tracks to that particular UDE, you put an X there under Debbie and Dave. You put an X that shows that that particular root cause, if it's repaired, will fix the throughput and capacity problem. Now, Mike said, hey, wait a minute, if you do address that root cause, it'll also address the problem I have with my UDE, and then with my other UDE. And then Wayne and Jose say, well, it does a partial fix on mine. So for a partial fix, you put in an O. For a hard hit, we call it a hard hit, you put in an X. And Roy has a hard hit on his problem with cables, and Armando has a hard hit with whatever his problem happens to be. So you go through and you put in the X's and O's that show if you nail it by fixing that root cause, you'll have a very positive impact on 1, 2, 3, 4, 5 of the different UDEs here. So we put in our X's and O's, and then we ask Debbie and Dave, is there any other root cause that you believe has something that must be done to fix your throughput capacity problem? Well, Debbie and Dave said, yes, there is another root cause. We don't have golden assets. A golden asset, if you've been in the old-fashioned engineering world, is when a perfect part was made. It was perfect in every dimension and weight and so forth. It was gold-plated and kept somewhere, so if you got something else that was pretty good, you'd compare it to the golden asset. So Debbie and Dave said, if we had golden assets, that would nail this problem we have with throughput and capacity. So you put an X in there. Now you've got two root causes or potential root causes for Debbie and Dave's problem. Art says, hey, that'll help out with my problem. Mike says it'll help out a little bit with this one. And Wayne and Jose, Eddie and Navid and Armando said, it won't fix our problems, but it does have some positive effect. So you put in an X that tracks that root cause to that particular fault or UDE, and then several O's that say there's a partial hit on those. It appears to me that Mike went out of order and did his root cause analysis before Art did his, but Art should have been there to do his root cause analysis where he mentioned it or identified that supplier lack of test equipment and or hardware was a problem, a root cause of his problem with supplier testing. And there's an X there, and it also affected several other UDEs. And then Mike has a root cause inadequate or no requirement slash process in place, and he put an X in there. And several other people said, well, it'll have a partial effect on mine. Eddie and Navid said it'll nail my problem if we fix that root cause. Roy and Navid said the same thing on this one over here on um, processes for XMTR or whatever it is. It doesn't matter, but you get the idea. Each one of these leads goes through and explains their particular UDE, and they explain what they believe the root cause is, and then the team chimes in on whether or not they think that root cause will have anything to do with their particular UDE. You do this all the way down the list so that each one of these leaders has a chance to explain their particular UDE and what they believe the root cause is for that particular UDE. And then we put in the X's and O's as a team. Here you can see that the matrix has been completed, and then we ask, does anybody else have anything else to add? And Debbie and Dave said there's another root cause I think we should address. We have insufficient supplier test equipment spares, and that would nail their problem. They said it would have a major effect on their throughput capacity problem. And so we added that, and a couple of other people said, yes, that should help us a little bit also. Notice when we got to Armando, and we asked for Armando to explain his particular problem, or maybe it was Roy and Navid explaining their procedures for transmitters or some problem that they had. They probably said, the work that we've done already has already answered my particular UDE. You'll find that often when you get halfway through or a little bit more than halfway through your listing of UDEs, the persons on the right side of the matrix will say, we can stop now, we've already addressed mine. The root causes you have listed have already addressed my fault. We don't need to do it again. And so you'll know that you're done with it, and then you revisit it one more time. You get everyone to go through it as a team. The leaders, of course, will say, hey, anyone have something to add? And the team will agree as a whole it's time to proceed. Last call, of course, is yours as the leader of the team, but you say, okay, let's move on and start doing our solutions. Now it's time to start developing the solutions and to track the solutions to the root causes. We'd start with the first root cause, and whoever owns it, and it can be any of these 4 or 5 people here now, they would start saying the root cause is insufficient test resources, personnel, and facilities. The solution to that is blank, and then write down the solution in the first column of the solutions part of the matrix, and then put an X in it because that solution will track to the root cause, and then drop straight down that column and fill in X's and O's the same way we did before, tracking root causes to faults. But now we're tracking solutions as a hard hit or a soft hit, an X or an O, to track the solution to the root causes. Here you can see that the matrix is progressing, and the person, probably Debbie and Dave, who led the first solution development, get more people, get more stuff. Put an X in there, and then they drop straight down the column and put in X's. And then the next person, who knows who it would, probably Mike. All right, look at the X's that track along to the root causes and up to the name for the fault. Probably Mike led the next one about write processes update requirements, and he put an X in there, and then they dropped down the column, and the team agreed that also is a hard hit on 3 more of the root causes. The next one, I'm not sure who led it, but improve the STE, sure, that's an X for insufficient test resources, of course, and then drop straight down the column, and the team agrees on where the particular solution will be of use solving the root causes, and so you enter the X's and O's. Here's an example of a Kiln where the team was saying, let's do these first 2 columns. If we can just get these things done, get them started, we'll have a very positive effect eliminating our root causes and thereby fixing our faults. So they said, let's do the first 2 columns. And then one of the people in the team said, well, wait a minute, look at these 3 that I'm calling solution set green. They'll get the same result. Look at our X's and O's. In fact, they'll get a little bit better result, and they cost a lot less. So let's consider, instead of doing the first 2 columns, do solution set green. Here's another example of a Kiln where they developed a bronze solution set and a gold solution set. And you notice some of them share solutions among the sets. And so they were looking at the gold set and the bronze set, and they did a cost analysis to see which one was quicker and cheaper to implement, because they both had pretty much the same effect. So it's up to you, but once you get a solution set and another solution set, they might share solutions among them, but one of the solution sets to implement might be a little bit cheaper and faster than another. So that's the Kiln. It's a little bit more complex than the FMEA, and a little bit more complex than the Pareto, and certainly more complex than the 5 Whys. That's why people don't do it. It's a method of last resort. When everything else has failed, try a Kiln, and a Kiln will generally work. It takes a little while to do it. It can take an entire day. It can take 4 days. I guess the longest Kiln I've done took about 9 days. But there were many, many, many problems and lots of different solution sets we had to consider. But if you have a doubt about how to use it, go through it very slowly, talk it over with your team or just a few people that'll be in your core team, make a dry run of the Kiln, and then do it. And if you run into a problem with that, contact your master black belt. Sometimes that's me, sometimes it's another master, and let them help you go through it the first time. If you've never done a Kiln on your own, it's a little bit tough to do. So try to get a little bit of help if you're going to try that. Thank you for attending this Sodexo Lean Six Sigma training. If you like this course, please click the thumbs up icon below the screen. If you want to be notified when additional courses are added or when courses are modified, Please subscribe to this channel by clicking the red subscribe button, also located below the screen. I wish you the best.